The second to last session of this evening is a quick fire session. There are 6 presentations by aerospace companies that all tie into the theme of space without a space agency. Our first presenter this evening is Mike Carey, founder and chief operating officer of Atlas Space Operations. Mike, if you want to come on stage.
Hey, thanks for joining us this afternoon. I know it's been a long conference, and it's been filled with a lot of dynamic and interesting topics, and I'm not going to disappoint you with this either. So if you could bring up my slide real quick, I'd appreciate it. I'm the one of 4 co-founders of Atlas Space Operations. It's a ground data services. We don't build satellites, and we don't sell antennas. We just provide communications to spacecraft owner-operators. Slide, please. So Atlas is a little bit more than just a regular telemetry, tracking, and commanding data services organization. We are also now connected with automotive, connected car, tracking of assets. We're working hard with the University of Michigan, developing special data links that can be used to track endangered species, to help people track family members that have some Alzheimer's perhaps, or where'd your kid go, where'd your dog go. Oil and gas is interested in some of our stuff. BNSF has reached out to us. So it's cross-sector. It's not just what we thought was going to be satellite owner-operators. It's actually part of a value chain that has really evolved because computing power and AI and machine-to-machine capabilities have really grown up in the last few years. Some of the concepts have been around since, I'll say, at least the 90s. But the technology has finally made it affordable. And in an industry that we're in, this is a very dynamic group of people, but our industry seems to be, in some ways, so conservative that's almost calcified and immobile. One of my last duties on active duty in the Air Force was to try to help the Air Force find a way to commercialize the satellite control network. We came up with 5 very reasonable executable options, and none of them could be implemented because one reason or another, either contracting rules or comfort levels with risk management or data security or one thing after another was the reason why you couldn't. So here all the right solutions are right in front of us, and we could not act on it. So when I left the service, the last thing I wanted to do was replicate the past. I wanted to innovate for the future. And so that's how Sean and me and Mike and Brad created Atlas. So Atlas Space Operations, and some of you have been hearing about us now for almost 3 years. Well, we finally came of age, and today is the first day that we tracked satellites with our own personally owned, commercially owned asset in Sunyani, Ghana, West Africa. Slide. So next slide. And that's Sean McDaniel, second from the right, with Gil Togano, far on the right. And then Mikel Akasuso is a brand new engineer that we hired, of all places, in Traverse City, Michigan. We were an Encinitas, California-based company. And while I was in El Segundo one time, I heard an investing board member, a panel member, mention the word Michigan, and you don't usually hear that in Southern California. And I learned that day that the investment opportunities and the cost of operations and the tech base in Michigan was phenomenal and ripe for somebody like us. So we pitched in March, and we closed tomorrow on a little over $1 million. So that was a pretty quick run. And so this contract with NOAA that required this antenna be built was issued in January, and it is June 29th, I believe. So 6 months from commissioning to operations. So that's pretty sweet. Go back a slide, please. So the taller guy on the right is Steve Gaines. Steve and I have known each other since 1985. We reported to Offutt Air Force Base to fly the Air Force's DMSP weather satellite. And he and I have known each other forever, it seems, and have done a number of things throughout our service and claimed that once we both got out of the Air Force, we'd go into business together, and we did. So Steve and I were up in Sodonkila, Finland, where we finished our site survey, and we'll begin groundbreaking operations in August for our Arctic site up north of the circle there. And those gentlemen that you see there are with the Finnish Meteorological Institute, and they're the the folks who are collaborating with us on that. So, slide. There you go. That's a blank slide. So you're not supposed to read anything or see anything. What I want you to do is know that this industry is ripe for visionaries who understand what could be done and are enabled by technologists and engineers who can actually make it happen. So if your team happens to have that dynamic duo, perseverance will get you there. I think that Atlas was starting over a couple different times. We've pivoted at least 3 different times. And we finally got the rock tumbler to polish the rocks the way we need it. Our Atlas Software Freedom Platform has really enabled us to work in the cloud and virtualize so much that the speed of data, the security of data, and the cost of data has gone down dramatically in how we do our business. We're very proud of that. Now, this is supposed to be about space without a space agency. But I will tell you that as much as we think that there's no space agency or regulatory, there's tons of it. And every country has their own way of doing it, and none of them are the same. And so it's an interesting education, and it takes a lot of perseverance in that regard, too. One of the benefits of coming from a very bureaucratic organization like the Air Force is I'm not stymied or intimidated by paperwork or process. It's just, I'm okay with that. Other people would probably, I don't know, be suicidal. I get closer to homicidal. So, slide. So this is what we think antennas should look like in the future. Right now, a parabolic antenna has a monogamous relationship with the satellite as it goes overhead. And because of that, there's a limitation on how many satellites you can support with an antenna. It's only 1,440 minutes in a day. You do the math, and you'll come up with something that says you can't possibly track more than X number of spacecraft in this frequency band in this period of time without buying more antennas. This device is a passive electronically steered array. This is our 0 model or our 1 model, beta 1, whatever, about 4 feet high. Our current model has it 5 inches high. It's basically like 1 ear. If you pepper out 8 to 10 of these things, it approximates in dB gain the same as a 6-meter antenna, except that it weighs about 200 pounds total instead of 2,000 pounds, and it costs about 1/10. Can track multiple spacecraft simultaneously with heterogeneous signals. So that is innovation in ground services. That is not replication in ground services. Slide. So what do? High quality data communications between ground and satellites, but we also do data harvest. The data has to come through, has to be parsed and sent to the right places. So we can do a lot of services, provide a lot of services for asset tracking, for big data, with satellites going up in the numbers that they've never done before. And the numbers can now allow you to do analysis on performance. Every satellite is a sensor, so there's space science that can be learned and extracted from all of that. This all comes through the same pipe. Slide. So in the Paris Air Show, Astrobotics made an announcement that we were also planning on going to the moon. With them with a laser communication device. Slide. Please tell me there's another slide. There's not. Okay. Anyway, the next slide was our antenna in Ghana pointing towards the moon. It was really dramatic. It was really cool. You were going to go, oh, wow, they're going to the moon. I guess what our point is staying ahead of the curve. We're thinking about the future, thinking about optical, thinking about lunar, thinking about adaptive arrays, thinking about something. There it is. Everybody go, ooh. For those who didn't, that's shame on you. Play nice, play nice. So that's early morning in Ghana right now, or yesterday. But we understand to stay relevant in this business, you have to stay nimble, but you have to perform and you have to deliver. So this image to me shows our delivery and our focus on the future. And we can't do it without the assistance of this environment, to include governments, but we're doing it without an agency. And what we find is that agencies like NOAA and agencies like NASA have actually turned to us and asked for solutions to some of their problems. And we look forward to being part of that solution set and a vibrant member of your community. So thanks for listening to me. Take a look at Atlas. We are a global provider of solutions, and we're excited to be here. Thank you very much.
All right, now I'd like to invite to the stage Ralph Ewig, founder and CEO of Odyssey.
Is that a clicker? Got it. All right. Thank you for making the time this very late in the conference to listen to me. So this is actually my last chart, but my first chart. I hope we can rewind this to the beginning. That would be helpful. But while this is going on, I'll talk to you a little bit. So I am the, there we are. I'm the CEO of Odyssey. Odyssey is actually my fourth space startup. And in the theme of this discussion, one thing I've learned over the various startups that I've started and participated in is that building your business model with the government as your anchor tenant, early anchor tenant, is not a good recipe for business success for a small company. And I'll tell you why. But that doesn't mean you can avoid agencies entirely, and you shouldn't. There are real benefits to be had, but you have to be smart about how you pursue them. So here's what Odyssey does, in case you haven't heard about us. This whole story really started with my time at SpaceX. I was responsible for communications for Dragon going to the International Space Station. And because commercial cargo delivery to space station is a NASA mission, we had access to a NASA relay system called TDRS, TDRS. What TDRS does is it allows you to bounce a signal from a fast-moving LEO spacecraft to a geostationary satellite network, and from there back to the ground. And by doing that, you have continuous access all the time to your satellite, no matter where it is. And I saw the contrast of having real-time, always-on communications versus using a network of ground stations, which even with a large number of ground stations was still very intermittent. So I thought, this is brilliant. People should do this all the time, right? Don't they? Everybody should fly their spacecraft this way. And the answer was, of course, they don't because they can't. TDRS, brilliant as it is, was built specifically for space shuttle and space station. It's in the wrong place. It's too far away to serve these newer emerging smaller platforms. And with that, Odyssey was born as a commercial idea. So what we are is a 3-satellite constellation, similar to TDRS, but in a medium of orbit, closer in, highly designed orbit. I'll get to that in a minute. And that allows us to serve this vast number of smaller satellites now going up, and we can serve any client below us, approximately below 14,000 kilometers, and you'll have always-on real-time communication, allowing you to get what Pete Worden once brilliantly coined as a phrase for us, a dial tone in space. Now, when you start working on communications in space, the very first agency you get to interact with, whether you want to or not, is the Spectrum Regulatory Agency. For those of you who've tried to put something into space, you'll be very familiar with this. But for us, Odyssey, as a small startup, which at the time was just 3 people, to go to an international agency at the United Nations and say, we want to occupy a large portion of the radio spectrum for this business we're building, and you should give us this license, it was really important to gauge our benefit, not just to say it's to our benefit, but it is really to the benefit of the entire industry and the agencies who regulate it. And to explain to you a little bit what's going on, here's a picture for you. So in the early days of space, 1970s to about 2010, space was geostationary. There's 2 images here. The top one is a view from orbit. The bottom one is a view looking up at the sky. And what you're seeing is satellites didn't move around much in these days. They're essentially stationary in the sky. And each satellite is occupying a certain amount of radio spectrum, and it's fairly easy to coordinate that process. Here's what's going on now. This is a single satellite in one day in a non-geostationary orbit. And in just this one satellite, in one day, it will cross a large region of space across the planet. And looking at it from the ground, you can see how it crisscrosses the sky. This is one in one day. Much more difficult to coordinate. This is what the future looks like. A single constellation, like the mega constellations being talked about by OneWeb, SpaceX, and other agencies, other companies, in 1 hour will irradiate the entire sky. Now, what this looks like is you have all 3 of these things going on at the same time, put on top of each other. Coordinating that is a serious nightmare. So we went to the Spectrum Regulatory Agency and said, look, every person who owns a cell phone doesn't have to get a license for their phone because AT&T took care of that for them. What if Odyssey were to use a large portion of the spectrum allocated for inter-satellite links, satellites talking to satellites, not heavily used at this time, and we can consolidate all of this traffic, all of this comm traffic from hundreds, if not thousands of clients with something very similar to a cell phone network and bring it all together in just 3 points, 3 satellites. Much easier to coordinate. And even beyond that, we specifically designed our constellation so that our orbit does not traverse the ground in a non-repeating pattern. So our orbit ground track actually repeats on the same cycle as the Earth's rotation, even though we're not at geo. So we trace the same line every single time. Much more easier to coordinate. And that really resonated with the agency, and then we went and applied for an international license, commercial license, early last year. We followed this up with the FCC in Washington, D.C. later last year. We just finished the industry public commenting period about a week ago, and we will be the soon-to-be-announced proud owner of several gigahertz of inter-satellite spectrum. This is unheard of for a startup. We're now a company of 9. It's a huge accomplishment. But it was only possible because we made it clear this isn't just for us. We're really helping to clear a logjam that's really stifling an entire industry. Going beyond that, we knew we started with NASA TDRS as an idea. We didn't want to compete with NASA. Even if you don't want to take money from the government because it has all these strings attached and there's overhead associated and it's not a good business model for a startup, you don't want to compete with the government either. So TDRS exists, it will continue to exist, and it will evolve. And there was no point to say we would replace it. So we reached out to NASA SCAN, which is the Space Communications and Navigation Group at NASA, and said, what are your plans for TDRS? How can we support that? How do we achieve interoperability between our 2 systems? And they were very receptive to that. So now we're looking at a model where a TDRS user, constrained by capacity availability, could fall back to using Odyssey. And it'll be just the same from their perspective. And at the same time, for us as a new provider, offering a service that's not yet proven, our customers can look and say, okay, we were willing to bet on you, but just in case it doesn't work, there's TDRS as a fallback option. So interoperability was very important from both perspectives, and there's benefits on both sides. So adherence to open standards was important. And then with that, there were additional benefits. NASA actually runs its own incubator called iTech. Again, not the best place to raise money or get money directly as a startup, but a great place to achieve validation and credibility. It's a 5-phase program that runs throughout the year. We participated in it. We were elected the top 10 innovators, one of the top 10 innovators in 2017. That got us great visibility. Our customer acquisition efforts absolutely became easier after that. People came and started approaching us. We had so many more inbound leads because an established brand name and recognized identity such as NASA said, yes, this is real. And we very much support it, and we're welcoming this new capability to the capabilities already existing and available to people. So then this got us thinking, well, there's a lot of money being spent by the government on building, evolving, maintaining the communications networks that we already have, deep space networks, near-Earth network, and space network. As a small company, though, I had learned I don't want to go after these opportunities. You end up getting very little money in the terms of today's startup enterprises, and there are a lot of strings attached. You have to deal with government accounting constraints, federal acquisition rules. There's a whole bunch of claptrap that as a startup you just don't want to deal with. What we realized, though, is that there are opportunities that prime contractors very much go after. That is their bread and butter, and they're certainly equipped to do so. And these opportunities have small business set-asides. So again, we're not going to go on FedBizOps and look for an opportunity and go after it ourselves, but we found this, Space Exploration Network Services and Evolution. This is an active RFP out on the street, put out by the government. It's an indefinite quantity, indefinite duration contract, 30 million plus a year, serious money. We could never go after that. But we partnered with a large established industry player who does. So now in this partnership, they take care of all the overhead that's associated in doing business with the government. That's what they do. They're familiar with it, and they do it very well. There's a set-aside in this contract that says, if we award this contract to you, the prime, ye shall share 20% of that with a small business. So they have the advantage of having a small, innovative team on their proposal effort. If the contract is awarded, we have the advantage we get money for doing something we were planning on doing anyway, which is interoperability of teachers' established capabilities with our system. Win-win on all sides. And then the last opportunity I wanted to share, which I'm also really excited about, maybe the most excited about, is the idea of rather than selling to the government as a customer, we can help the government take resources which they have already created and make them more accessible to commercial users, and then drive our business that way. So the example of that is CASES. CASES is the organization that manages commercial use of the International Space Station. It's a fantastic resource, a human accomplishment that has few equals, and they have this mandate of go out to commercial users, not just space users, but other companies like biotechs and pharmaceuticals. If they would like to run an experiment on space station, they will go to CASES, and CASES manages that process. For these companies, they do not understand space communications. They don't care to understand space communications. They want to set up their ant farm, plug in their webcam, and fire up a computer on the ground and see how it grows. That is what we can do. So we can deploy a terminal for Odyssey linkage services on a space station, and thus enable a government-built asset, which is a huge asset to everybody, truly, become available not just to space companies, but also to not space companies by making this process just that easy. All you have to do is get it up there, plug it in, and it works. So in the end, this has really been a learning experience for me over the last 4 companies I've worked through, and I think the real big insight is this. Yes, you don't want to build your business model around selling to the government. For a young company, it has all the trappings that will kill you. It's too slow, it's too cumbersome, it's too complicated, and you can't innovate. But there are absolutely benefits to be had to engaging with the government and integrating it into your business model if you do so smartly. Thank you.
Okay, next up is Simon Halpern, CEO and founder of Phase 4.
Thank you. Okay, test. Thank you very much. Ralph's talk was very appropriate, so you're going to laugh when you see a couple of my charts. My name's Simon Halpern. I'm the CEO and founder of Phase 4. We're building a new type of electric propulsion system designed initially for small satellites, scalable for much larger applications. So this was a very interesting subject for a discussion today, and for anyone who's been living under a rock, you may not be aware about what's going on in DC. The subject of this quickfire, some might argue, could become a reality at some point. If Trump has his way, no space agency, something like that. It's not obviously totally true, a little bit hyperbolic there, but this is kind of what's happening. So at Phase 4, how do we, in the electric propulsion world, how do we think of dealing with life without a space agency? So let's just take a look at where electric propulsion is today. Today's electric propulsion technologies tend to be government funded, just the way the world. These systems, these EP systems, can take years or decades to build, and you end up with breakthroughs on the order of decadal timescales. And so when if you think back a couple days ago to when Steve Jurvetson talked about Moore's Law, and anyone who's familiar with Moore's Law knows that if you're doing anything exciting on a 10-year timescale, you've already lost. So what you end up with, a lot of systems today, you end up with really cool CAD drawings or computer-aided models. You end up with awesome science experiments. A lot of people earn their PhDs based on doing all sorts of ground experiments. But you end up with what I like to say, what are experiments and not products. So this is taking Ralph's points into account here. So Phase 4, of course, like many electric propulsion companies, got started on government grants. We had a DARPA grant managed through NASA, and we partnered up with a federally funded research and development corporation, Aerospace Corp, to get this thruster built and tested, and more testing, and just test. And throughout this whole process, it was a little over a year, this one phrase kept coming up. I can't really see the audience, but by show of hands, has anyone ever heard the phrase, "That's how we've always done it"? Yeah, so that phrase came up a lot. And just breaking that phrase down, which is probably something that somebody in the government will tell you if they're managing your contract. When you're going to space, you have to do things a certain, you have to meet certain standards, you have to be safe, et cetera. And so my argument is that there are different ways to meet those standards, and just because you've always met a standard a certain way does not mean you have to do it that way forevermore. I thought a little bit more about that phrase, and I spent about a decade working at Northrop Grumman, and I've just heard that that's how we've always done it quite a bit, and it was, I wanted to get away from that phrase. So first, beginning part of the company, that's how we've always done it, was beaten into us, and now that's kind of a fireable offense to even say that at Phase 4. So shifting gears from being government funded to being venture funded, in the same time frame, a little over a year, from going from a concept to a lot of tests for the government, we are going from proof of concept, so on the left side of the screen, that is our thruster producing plasma and producing thrust in a vacuum chamber. Actually, at the culmination of the government contract, we're building out a complete R&D and production facility rapidly, something on par with, at least R&D-wise, with anything you'd see in a national lab, but production-wise, I suppose, on par with something it'll look prettier at some point, but something a little more commercially rapid-fire kind of thing. And at the end of this roughly 16-month time period, we will be testing this thing in space. We've already purchased a satellite and a launch, and we are demoing this thruster on a 6U CubeSat. Should be the first quarter of next year if SpaceX stays on time. So this is what we're launching next year. The mission's called Rose 1. To harken back to my working with the government days, we put an acronym within an acronym. It stands for RFT, Orbital Satellite Experiment, Radio Frequency Thruster Orbital Satellite Experiment. Go figure. And this is something we're doing on our own. The government has expressed interest in understanding how the thruster works in orbit. Obviously, gaining flight heritage is going to be critical for working with the government. I certainly don't want to think about life without a space agency. I don't think that will ever become a reality, but this is something we're doing on our own time frame for the commercial customers who say we want to see testing, just like the government does, but we also want to see it fly in space, and we want you to do that all very quickly. So that's what we're doing. We're bringing in a new breakthrough. Hopefully, it's been a couple of years now, but new level of performance and a service level component that you don't typically see when you're buying propulsion hardware. You're buying hardware. You're buying components from a vendor. And in our case, you're going to be purchasing the hardware as well as a service level component that I'm happy to talk about offline or after the conference a little bit more. And I think that kind of ends the time here. So I appreciate everyone coming out, and thank you very much.
All right. Next up is Ryan Holmes, founder and CEO of SpaceVR.
Hi, everyone. My name is Ryan Holmes. I'm the founder and CEO of SpaceVR. We're going to be launching the world's first virtual reality camera satellite here later this year. In the next month, it'll be fully finished. Here you can see it right now where it is at Pumpkin's office. And so, as many of you know, doing things in space takes a lifetime, right? It takes a long time. And so, as our first satellite's wrapping up, I'm starting to think about what we want to do, what we want to dedicate our next lifetime to. And I start that quest by thinking about what I want to happen. I want us to have the biggest and the best space civilization we can possibly build. And to have that, you have to look at the limiting factors. So right now, the limiting factors are simple: energy, atoms, and labor. For energy, you can use solar panels, somewhat solvable. For atoms, you have SpaceX. They're getting the cost down. But for labor, there's no real solution for this. It's like the final bottleneck for space. And as we're looking through a bunch of new space companies here, everyone seems to lean to one solution, and that's robotics. Currently, we only have 6 people in space. That's just not a lot of people to do a lot. And as anyone that works with those people knows, their whole schedule's booked out solid. And so just with a quick price analysis, and this is being, I would say, overly fair, because I'm calculating this against SpaceX crewed vehicle. Over a 10-year period, it's a $200 million for a person to go to space. But if you were to launch a robot, it would only cost $2 million and last over that 10-period lifetime. So that's a 100x reduction in labor costs. So if for 1 year, NASA used their budget, for just 1 year, they could launch 100 robots instead of 2 people. And that would multiply the labor effectiveness by 50. And that's not completely fair, because you also need a communications constellation to talk to those robots. So I'll go 2 people or 50 robots in one communications network. So after looking into robotics, I thought, what's the best in robotics? What's the best of the best? And here you can see the Boston Dynamics Atlas robot. And at first seeing this, I thought, wow, that's incredible. It's able to pick up a box, stand up by itself. That's really impressive. But at the same time, I thought, why do robots suck? They're not able to do anything we really want them to do. And so I concluded that they suck because their brain sucks. The way they process sucks. And if I were to want to solve that immediately, I would simply switch out the current brain with the human's brain. And so that's what we're doing. I'd like to introduce you to our first robot. It's called Human. And it works, it's powered by a human. It has 2 arms, full range of motion, and a low latency 360 3D camera. It's controlled through a VR, using a VR headset and VR gloves. So I realized that launching hundreds of robots into space and creating a low latency communication network is not a simple task. Some would say it's non-trivial. So I want to focus on something that we can do on Earth first. And here's the 3 major benefits of our robot. 1, a single person can control multiple robots at the same time, so it allows someone to do multiple things at the same time. The second thing is anyone can work from anywhere. That's probably the most important aspect. And the third one is that you can start collecting a lot of data about the robot working in specific environments, and then slowly but surely you can automate those tasks. Say washing dishes. After 1,000 people wash dishes, you could eventually figure out how to automate the washing dishes task. The main benefit that we're going for is the ability to lower labor costs. So the dream of a fully artificial intelligent robot would lend to a robot that has no labor costs. So I just mark that here at 1%. And the current cost of a person at 100%. So simply by using a lower cost labor source, you can get 90% of the cost reduction of a fully functional artificial intelligence. So not even at 90%, say we only did 20% of the labor savings. These are the kind of numbers you would see large companies in the world experience. With human intelligence, we can outperform all companies. Boston Dynamics, who recently purchased by SoftBank Robotics, KUKA Robotics, all these companies, and there's so many more that are gearing up to do autonomous robotics. All these companies are depending on some magical solution that's going to come out of nowhere that's fully artificial intelligence, that's going to just know what to do. And if we look at that historically with Tesla, it's not going to happen that way. Tesla cars had to drive hundreds of millions of miles before they were even close to just do highway automation. So it's not just going to magically happen. We need to train the artificial intelligence through robots, and currently there are no companies that are set up to do that. So our model's simple. Without going too much into detail, we charge 20% less. So we just peg it at $20,000 a year. Over a 10-year period, each human will make in profit $116,000. So if you extrapolate that, it's the model of making money is simple. Just deploy more robots. And so we made a simple graph, starting very modestly at 10 robots and growing it up to 10 million robots. We can go from 180,000 to 180 billion per year. And just for scale and manufacturing, Toyota makes 10 million cars per year. So it's doable. Just for fun, I added this video. So this is we just got this robot in, and I was controlling joysticks. You can see like the current level of sophistication that we're at. To the right here, you can see the hand that we're going to shortly be replacing the gripper. But eventually, I was able to scoop some ice cream. I'd like to invite you guys to our ice cream demo. In a month, we'll be demonstrating our first human robot, right here in San Francisco, July 15th. So you guys are welcome to send me an email and come and see the world's first robot operate through virtual reality. Right now, we're also looking for really passionate robotics engineers and really passionate investors. So if either of those are here, please email me at this email. If you have friends that are robotics engineers or software engineers that like automating all jobs, that kind of stuff, go ahead and send me an email. Thank you.
All right, thank you, Ryan. Next up is David Shaw, co-founder and CCO of Astrapi Corporation.
Finds and controls an entirely new field, which is what we call spiral modulation. And spiral modulation addresses the spectrum crisis or spectral efficiency. So we've heard a lot about all the money flowing into space privatization. So the question is, why would the private sector or the agencies have any interest in something like spiral modulation? Well, if you take a step back from it, we gather and communicate information from space. I mean, that's why basically, fundamentally, everybody's here in the room. You take it a step further, successful communication links are what define a successful mission. So existing channels are capacity constrained, power constrained, and susceptible to increasing amounts of interference. Yet we demand more. We want larger data files. We want more sophisticated devices to capture the information. Unfortunately, those require more power. They generate more interference. They create bigger challenges. Well, that's why we were organized, was to alleviate those challenges and address those opportunities using spiral modulation. So if you look at the three pillars of deep space communication in reducing data rates, they're built around collecting massive amounts of scientific data, using incredibly sophisticated imaging instrumentation to facilitate humans in deep space. So it's all about the data collection first. And the space systems, they gather the information, allow us to assess it. Many times the link is used to repair unmanned vehicles. And of course, it's more acute for humans in space. But there's some other things going on here. If you consider distance, it's 100 times more difficult to communicate to the moon than geosynchronous orbit. If you get into the estimates of what we need, NASA estimates the communication capacity has got to increase 10x over each of the next 3 decades. So I want you to consider these two graphs. The one on the left is the theoretical limit, the curve. If you look on the one on the right, that's the historic data rate curve. You'll immediately notice they mirror one another. You'll also notice they flatten. There is no exponential growth to meet the demand, right? So how do we solve that? Well, right now, it's you look at lasers or optics. They're expensive. They don't have a long lifetime in space. They've got issues with noise and atmospheric conditions. You can look at channel coding alternatives. Well, they rub up against the theoretical limit. You can look at compression, but that's got a huge overhead, a burden computational overhead. Emerging software-defined radios provide some flexibility, but they too rub up against the theoretical limit. So, what we call, I guess NASA's characterized it as a capacity approaching limit. We call it the upper bound on spectral efficiency, or the Shannon limit. And the current way to construct signals is using sinusoids with constant amplitude. Well, Astrapi was founded by Dr. Gerald Prothero. Gerald invented spiral modulation while exploring the core mathematics. And it turns out there's some really interesting things that happen if you begin to construct signals using a non-stationary spectrum, highly non-stationary spectrum with continuously varying amplitude that are generated by the use of spirals. And in this example, if you compare the lower row to the upper row, you'll immediately see that spiral modulation allows you to completely redefine how you use that communication waveform design space to improve trade-offs for data throughput, bandwidth usage, signal power, error rate, and so forth. So there's no prior art on this. We've got over 40 patents issued or pending among 10 patent families. We've raised a little over $2 million to date. We won a National Science Foundation Phase 1 award. The EE Times named us to their Silicon 60 list of emerging companies to watch. We now have 4 global research institutes that we're working with, so it expands our R&D capability. And significantly, the reason why we're here is we won the inaugural Startup Space Pitch Competition back in March, which was sponsored by the Space Frontier Foundation. So we really appreciate the opportunity to present here today. So are there challenges? Well, you bet. Protecting and extending our IP portfolio is a big one. Ensuring there's alignment with stakeholders is critical for early stage companies. Austerity, frugality is a front of mind all the time thing. You heard about employment, labor, attracting labor. That's actually become a really good opportunity for us. There's no lack of really sharp people who want to work on something important, who want to create something important. And of course, there's technical risk. Well, that to this audience is the norm. For us, each problem we solve, each challenge that we address has likely got an entire patent family that's going to fall out of it because there's no prior art here. So getting back to the agency question, can it work? Well, yeah, if there's alignment with your technology readiness level, it can work quite well. The money's non-dilutive. You may have a contract on the back end of it. On the other hand, that contract subjects you to federal contracting, which can be quite onerous. You may or may not control your intellectual property, and you most assuredly aren't going to be able to have alignment with the funding cycles, which is an issue. So spiral modulation's much bigger than Astrapi. We're looking for risk-tolerant people to get involved here. We're looking for development partners. We're actively seeking a round of financing right now. If it means we use agency funding, so be it. If it means we use private funding, so be it. As a practical matter, we've done both, and it's sufficiently big enough and important enough, we're likely to continue to do both. We like using the phrase ad astra, which you've noticed in 2 or 3 of the other presentations here, which means to the stars, reach for great things. What's almost always left unsaid with that is per aspera, which is through hardship. So put another way, if you're not dealing with something incredibly challenging with an awful lot of hardship, with audaciously big goals, you're probably not working on something very important. Spiral modulation is incredibly important and offers a really exciting solution to optimize spectrum and deal with spectral efficiency. So again, your successful communication links are what define mission success. They critically define mission success. And the reason why we're all here is fundamentally to gather boatloads of scientific data and deliver it back to Earth. Ad astra, y'all. Thanks.
Thank you, David. Our last quick fire this afternoon will be given by Shane Fleming, VP of U.S. Operations at Rocket Lab.
you. Thank you. Thank you very much, Viviana. It's a pleasure to be here today, everyone. My name's Shane Fleming, and I'm representing Rocket Lab. Rocket Lab is a small, dedicated launch vehicle provider. Go ahead and get started. So Rocket Lab was founded just over a decade ago by Peter Beck. The company is headquartered in Huntington Beach, California, and in 2009 became the first private company in the Southern Hemisphere to reach space. Today, we employ over 150 people globally, and we have launch operations in New Zealand, and production operations and customer integration support here in the United States. The key objectives of the company are quite simple. Really, to enable disruption of the small satellite market, liberate the small satellite market, we want to do two things. One is to reduce the cost of launch, and the second is to increase the launch frequency. It's very important that we do both of those things. So starting from a clean sheet design, what we've done is we've developed the Electron launch vehicle. It's a fully carbon composite vehicle. It's 55 feet tall and 4 feet in diameter. It throws 150 kilograms to a sun-synchronous orbit at 500 kilometers. And our ultimate goal is to launch one a week at a price point of $5.7 million US. The Rutherford engine is something that we're very proud of. It's fully 3D printed engine chamber, alloy engine, and it's fully developed in-house by our team at Rocket Lab and produces over 5,000 pound-force of thrust per engine. We've got 9 engines on the first stage and 1 engine on the second stage. You can't give a presentation in Silicon Valley or in San Francisco without highlighting our Tier 1 investors, so just want to give a shout out to Coastal Ventures, Bessemer Venture Partners, and Data Collective. It's quite appropriate that Sunil's going to be speaking just after us. And also wanted to thank again our customers at Planet, NASA. We've been awarded a Venture Class Launch Services contract, Spire. As Amanda mentioned earlier, Moon Express is also flying on Electron, and Spaceflight Services has also just recently purchased a vehicle. So we're very thankful for that. So a lot of people ask, why New Zealand? Why are we launching from New Zealand? And the real answer to that is, we went and talked to a lot of the ranges in the US, and the launch availability just wasn't there. The infrastructure is old, and the cost for us is just too expensive. When we looked across the globe at areas where we could launch and look for launch availability, we found New Zealand in the South Pacific, and it's really this geographical gem. There's low air traffic, low sea traffic, the weather is good, and it's an English-speaking country with very close ties to the US. So when we found this particular spot in New Zealand in Mahia, it has a very wide orbital plane range, for everything from 39 degrees to sun-synchronous. And so being able to own and operate and have full control over your own range, be able to develop that infrastructure from the ground up is very important. And that's why we've based our launch operations in New Zealand. So of course you can't just show up and launch a rocket from New Zealand, especially when there was no space agency. So to kind of highlight the topic of this quickfire panel, New Zealand was signatory to the Outer Space Treaty, the Moon Treaties, but they had no domestic launch capability. Once that was developed, it was quite clear that we needed to pull the space legislation to be able to develop that. So Rocket Lab helped really kind of pull the local industry in New Zealand to develop the local legislation and help enable and create the New Zealand Space Agency. And we're very, very excited that New Zealand recognized the potential and the growth in the space sector for the region, but also that it enabled the US and New Zealand governments to collaborate and develop a bilateral treaty, the Technology Safeguard Agreement that enables space launches to occur from New Zealand. So now I just want to show a quick video of our recent test flight that occurred just over a month ago that the team is very proud of, our first test launch of It's a Test. Could I get a little bit of audio?
I'm sure most of you guys have probably watched this, or I hope at least some of you have watched this on YouTube over and over again. I know I have, but it was quite a proud moment for the company. As you can imagine, the excitement from a first test flight of an orbital launch vehicle, getting off the pad, achieving stave separation, second stage ignition, and ultimately fairing deployment. So we were extremely proud as a company and as a team to pull that off. It's been a really, really tough 3 or 4 years. And with that, we are ramping up U.S. operations in Huntington Beach. We're developing our production facilities around engine and avionics development. So if you know anyone who's interested in building rocket engines and has top talent, we'd love to speak with you. Thank you very much.